Bonding in metals. We mentioned the electron C model for metallic bonding at the beginning of the chapter. We'll talk about it a little bit more now. Metals have low ionization energies, and part of this is because those valence electrons are held rather loosely, so it's easy to pull them off. What happens in a metallic solid, and this happens in an alloy, which is a homogeneous mixture of two or more metals, and it also happens in a pure metal, is that each of the metal atoms donates one or more electrons to this electron sea, this ocean of electrons, this pool of electrons. And then those electrons just kind of swimming around hold those now cations together. And so there's this attraction between these metal cations and this negative pool of electrons that surround them. And that's what holds the metal together. This explains conductivity and malleability and ductility, three of the most important properties that metals have. A metal can conduct electricity because there's electrons swimming around. They're not attached to a particular atom. Electricity is the flow of electrons, and these electrons are free to flow, and so metals conduct electricity. Nonmetals do not. Malleability and ductility. Malleability is that you can smash it with a hammer and you're going to dent the metal. It's not going to shatter. You know, if you take a block of tin and you hit it with a hammer, you may make a dent in it, but it's not going to shatter. If you do that with a big salt crystal or maybe a quartz crystal, it's going to shatter. Ionic compounds shatter. Because we have non-directional attraction, these sodium atoms are attracted to this mobile sea of negativity, negative electrons. So if we smash this and move one of these atoms a little bit out of position, it's still attracted to the electron sea around it, and it doesn't affect it much at all. It just gets moved. In an ionic compound, we have attractions in all directions, but if you smash it and you move a sodium ion a little bit, you're going to push it towards other sodium ions which repel it, and you're moving it away from the chloride ion that it was attracted to. The distance there matters a lot, and so you greatly weaken the bonds, and they'll tend to just shatter. Ductility is being able to draw something into a wire, and that's the same idea. The non-directional attraction between the metal ions and those electrons allow it to be deformed. Any questions? And then this has nothing to do with metallic bonding, but here it is. I think this is good to understand because ozone is important, right? We all know that the ozone layer is in danger and that has impacts for climate change and everything. There is chemistry going on in the ozone layer, and that's why the ozone layer is beneficial. So here we have an illustration. We have ultraviolet light coming from the sun. Ultraviolet light is damaging. It gives you bad sunburn, it can cause cancer, all kinds of bad things. So the ultraviolet light coming from the sun hits our atmosphere. On the outside, we have this ozone layer. Well, ozone has weaker bonds than the double bonds in oxygen. We looked at the resonance structures for ozone. It has kind of a 1.5 bond. Well, a 1.5 bond is weaker than a double bond. So that ultraviolet radiation has just enough energy to break that intermediate bond in ozone, but not enough to break the double bond in oxygen. So the ozone will decompose into oxygen and an oxygen atom. Let's write that out. So we've got O3 plus energy in the form of light makes O2 plus O. Now, is this oxygen atom happy? No, it isn't. The ultraviolet radiation has been absorbed by the ozone molecule, making oxygen and another oxygen atom. The oxygen atom doesn't get affected by the ozone because the double bond is too strong and it won't break. But this oxygen atom then will recombine with the oxygen to form more ozone. And so the ozone layer does not get destroyed by the ultraviolet light. But things like chlorofluorocarbons can destroy it because they mess up this reaction. Any questions? End of the chapter.
That was a short chapter.